Well, hello and welcome to the latest in our series of shorter podcasts previewing the ASI conference in Nice. And our guest today is a speaker who will be in the session that I'm chairing, focused on advances in data science and modelling. Mario Paich is Chief Data and Research Officer at Ipsos. So welcome to the podcast, Mario.
Thank you, Richard. Good to see you.
Firstly, can you give us some background about what your role at Ipsos entails nowadays?
Sure. So I've been with Ipsos for almost 20 years now in various roles in different countries, even continents. Basically, my current role is focused on business development and strategy. And I'm a sort of a go-to technical person for the whole portfolio within audience measurement business at Ipsos. So mostly focusing on major audience measurement tenders and trying to keep in touch with all the latest developments in audience measurement and working closely with our local teams. We do audience measurement in roughly 40 countries. So there's a lot of work on the current projects, but mostly focused on the future and the new business.
Now you're talking specifically at the conference in Nice in November next month, or less than 4 weeks ago.
Yeah.
At the time of recording, you're talking about synthetic data. What's meant by that term, and how does it relate specifically to media research?
Yeah. So outside of our world, let's say, what's meant by synthetic data, basically any information that's artificially generated rather than produced by real world events and being measured and observed. Typically, this is created by algorithms, and it has many uses, again, outside of our world. Benefits of it, the data minimizes all the constraints that you might end up with regulated, very sensitive, privacy-sensitive data. You can also customize synthetic data to match in a better way the conditions of real world that you might not be able to collect by using different methods, and you can generate large data sets or at scale and minimizing the cost. The biggest use these days of synthetic data outside of our world, again, is to train machine learning models, and that's been something that's seen as a way of overcoming some of the challenges that the modern AI and machine learning practice has been faced with, in terms of collecting enough information to train these complex models. But there's other use cases, some of them going back years. If you think about trying to model physical modeling around music synthesizers or flight simulators, all of that relies on synthetic data. In terms of how we use it and how does it relate to our world, in the most obvious use case, and the one we use the most, is to create synthetic population data sets and use them as a foundation for audience data. As you know, data integration has become a critical component in audience measurement. We do integrate many data sets together in order to get to our final audience data. And synthetic population data offers a representative frame into which all these data sets can be integrated. And most importantly, allows us to preserve data privacy from all inputs, especially if you think about panel data, if you think about census data. The goal here is to reflect statistical properties that were observed in original data and contain it in a regular data structure that we are used to, that we can analyze using our standard tools. So we're still talking about respondent level data in a way, but the traditional respondent level data has limits in terms of what can be integrated, mostly because of the constraints around the variance available in a fixed set, such as, let's say, 5, 10, 20, 50,000 respondents is nowhere near enough for the things we're trying to do these days. And this synthetic population data, again, as a foundation, allows us and offers far greater degree of freedom in terms of integrating, calibrating data, and bringing everything together. So that's where we see use cases. Some examples, maybe, if I can just and again, this is not a new thing. It's been with us for some time. It's probably the use of synthetic data is increasing. But if you go back years, you think about data fusions and traditionally how we did it by fusing two data sets together, splitting weights, creating virtual respondents, basically. Same goes with, especially what we draw a lot of this expertise from is out-of-home research, which is, if you ask me, still the most complex media to be properly measured and reported. So many years ago, we started with hybrid methods of bringing traffic census data with people measurement. And this is where we started creating those virtual contacts and virtual sort of data sets. But some new examples I'm going to touch on in Nice will be obviously what we do at Ipsos, with Ipsos Iris, where we have 1 million synthetic panelists representing the online population, where we then integrate all the data sets together. Another one sort of out-of-home solution in France, which is just about to be launched, where we have 8 million people in a synthetic population, where we try to simulate all of their journeys. And there's also, as you know, in Australia with OSTAM, they're doing their virtual Oz dataset, which is essentially a synthetic population data. So those are some examples. I'm going to touch on some of them, obviously, during my presentation.
So to a non-statistician, it sounds a bit like cloning or something like that, where you have an original respondent and create many respondents. But I guess if all it was cloning, that wouldn't be much use. You would just end up with lots of people with the same characteristics. So how do you decide how to change the clone from the original, so you generally have got a million different people as opposed to
but you base, again, going back, the goal is to reflect the statistical properties of original data, and synthetic population is about representing the population. So you take the census data, obviously about population size and characteristics. You take our establishment surveys, which bring more information into that which is not measured in the census, and you create a frame, which is basically essentially sort of a shells of respondents, let's call them, with some information attached to them. And then you can decide how big the size you need, depending on the population size and also depending on what you're going to integrate into that. But basically, this is where we start with creating this synthetic population as a frame. And then you start fusing in. That's where sort of your cloning and traditional fusion methods. So you take panel data, for example, and you fuse it into the synthetic population data, where you expand your panel of, let's say, 10,000 people onto a million, and still trying to preserve what you measured. And then you might have obviously other data sets coming in. You might have census data. You might have some of the metrics you have to calibrate from census. You attach it to those panelists, which are now expanded to this synthetic population. You might have other sources. I'll give an example in Nice, how we on Iris sort of, you have 3-4 different data sources, and some of them you use just for one metric. Some of them you might use just for one publisher, because there's a server-to-server integration in place. But basically, going back to your question, it starts with that foundation, which is synthetic population, and then you fuse panel data, which you use mostly traditional fusion methods with some additional modeling and machine learning in place.
Cool. I know this builds on presentations you've given at past ASI conferences. You've spoken with UConn before, and also with regard to the BBC Compass survey. And a theme you've discussed before is the balance between measurement and modeling. And obviously synthetic data sounds a really good move, but equally some might be concerned, is it moving too much towards the modeling and not the original respondents? Where do you think the optimum balance lies between survey-based traditional sample surveys and modeling and algorithms and virtual respondents?
Yes, I've been sort of discussing this, and the industry has been discussing, obviously, that particular challenge of measurement versus modeling, or how do they sort of work together, and what's the optimum balance, as you say. It's literally, as you know, the challenge for audience measurement as a practice is that it's becoming increasingly difficult to actually measure real life events and sort of bring everything together by single source measurement or even multiple measurements. It's becoming difficult. So modeling has been with us for many years, I'd say decades. So again, I always try to sort of emphasize that it's not a new thing. We have accepted modeling as part of our toolbox and it's been with us for many years. Obviously, it's not a magic wand, which you cannot overcome some of the measurement issues just with applying a model on it and trying to simulate something. So I think where we are now, where sort of the balance is the hybrid approaches, where data integration is the norm. But what we're trying to do is basically use the best possible source for each specific thing we try to measure. And again, this can be a measurement of a specific platform, even specific publisher, a channel, a specific metric, that we can sort of take some data from another source and put it into our core data set. So I think difficult to say where is the optimum, but for if you think about something such as sort of TV measurement and extended video measurement, it's still rooted very much in panel measurement, and you need that people measurement element, especially around measuring multiple platforms and the overlaps. So that's not going away, and you're trying to preserve those estimates that you measured. But there's other ways of other better sources of some other metrics or data that we cannot measure on the panel, as you know, especially around sort of walled gardens and what goes on in the obviously digital space. So that's where we start bringing data from other sources, and it's all about using the best possible source. So the balance, it depends on that, I guess. But still, the core element is still measurement of people, as we know, and it's not going to go away.
I mean, you're right to say that modeling has been around for decades now, but I think it's really only in the last 5 or 10 years that the phrase data science and data scientists has been used so much. What's, from your perspective, what's the difference between a statistician and a data scientist when it comes to media measurement specifically?
There's this sort of, usually when people try to describe it, there's this funny phrase, sort of, let's say that a data scientist is someone who is better at statistics than any software engineer, but also better at software engineering than any statistician. So it's basically, data science is defined as a sort of a confluence of 3 areas: computer science, mathematics / statistics, and specific domain knowledge, in which in our case it's audience measurement and media, right? Media research. So all measurement companies, all big market research companies have been investing in this type of resource for many years. We might have called them differently in the past, and we started calling them data science, as you said, relatively recently, but we have all been investing in that for many years. Example of Ipsos, specifically audience measurement business line within Ipsos, we went from a team of roughly 6 people in 10 years ago. Now we have 35 people in London working exclusively on audience measurement projects within data science. And it's not, we call it data science, but we're sort of thinking about extending that, and we're now calling these teams data teams because they now incorporate other functions. So we have data scientists, again, people who design solutions and try to find solutions to our challenges. But then you have data engineering, people who build pipelines and put those solutions in production. You have data operations, people who run those production pipelines and make sure that things happen every day or every week. And then also importantly, we started investing and putting people in place in sort of data product management. So people who can talk to people outside of their core data teams, which is very important to bring those functions together and translate the language that's usually very complex. So in that sense, this is all now a norm, and it's happening across the industry. And we are all investing heavily in that. Again, going back to the challenge that measurement has become very difficult, and it's more about data integration these days, to be honest. But we are sort of, there's this myth that market research agencies are very much behind in that sense. I would always argue that we are not. The size of data that measurement companies are working with is enormous. If you think about census data, any measurement company collecting census, we are talking about serious sort of data sets that are comparable to some of things that we would never compare ourselves to. And when you talk about complexity of our models and machine learning in use in audience measurement, it's all up there. So this is where, again, we will continue investing in that, as we know things won't get easier for measurement, right?
So finally, you're speaking and taking part in my session on Friday afternoon at the event. So before that, there's 2 days of measurement discussion going on. What are you most looking forward to getting out of this year's ASI event when you're not on stage and can be enjoying other people's papers?
Yeah, I will try to enjoy. Obviously, I'm presenting at the last day. Never a good thing, but definitely for all of us, not surprisingly, we're all looking forward to just seeing each other. This is going to be a special year, obviously, after a number of years that we couldn't do this in person. And we all enjoyed the virtual sessions. Obviously, they were really sort of really well made, and I think we needed that. But obviously, this year we're all just looking forward to see all the people we haven't seen in years. In terms of obviously, always for me, it's the core benefit of the ASI is just finding out what's going on and what other people do. Obviously, looking a little bit about what competition does. So I'm mostly looking forward to the session on Friday morning. New developments in measurement, where it always gets interesting, at least for us who are in the weeds, right? And also very much looking forward to our session with you and with Pete and Andrea, who are all were very established, well-known practitioners. Very looking forward to talk to them as well. So yeah.
Yeah, it should be a good session. Also, people who are, I think, good at explaining to non-statisticians in the audience, the terms and why it matters. So it's not a session for non-statisticians to be scared of. It's
exactly. We'll try.
And our job is to make it as accessible as possible.
Yeah.
So, well, thanks for that. We're almost at the time of recording. We're almost at capacity for the event, but listeners can check on the website to see if tickets are still available. And if you are attending, then be sure to make it to Mario's paper. In the meantime, thanks for your time today, Mario.
Thanks, Richard.